Well, hello, we're going to have a look at the questions relevant to Chapter 1, Section 6, which is only two questions here, 24 and 25. So 24 says, find all right triangles with sides of integral length, such that one leg differs by 2 from the hypotenuse. Well, here's the word solution for this. So here's our triangle, and I'll just label the sides A minus 2 and B. Now if we want primitive triads, firstly, that is all of the three sides have no common factor except 1, then we either have the hypotenuse has to be u squared plus v squared for some integers u and v, and either we have the b is 2uv, and then the third side u squared minus v squared, which is a minus 2. But then if I combine these two together and subtract, then I simply get u squared plus v squared, which is a, and a is u squared minus v squared plus 2, and when you simplify that gives you v is 1, and that's one possibility, so we'll hang on to that one. The alternative is that a again has to be u squared plus v squared, and the b then is u squared minus v squared, and then the other side is the 2uv. But once again, when you replace the a, you get u squared plus v squared, then is 2uv plus 2, and these terms you can bring together as a perfect square, and you get u minus v squared is 2, and that's impossible. So the only possibility for primitive triads are when v is 1, and that gives me, this is the hypotenuse, and these are the other two sides, which gives me u squared plus 1, 2u, and u squared minus 1. These two differing by 1, where u is any positive integer. Now, for the case of non-primitive triads, then in that case, the formulae are a little bit more complicated. So in that case, we have k, this is the hypotenuse. Once again, the option doesn't work for the other possibility, so this is the hypotenuse, and it differs by 2 from one of the other sides, which is 2uvk, and again we can factor out a k from these terms, and we get a perfect square is 2, and the only way that can happen then is either k is 2 and then u minus v is 1, so u is v minus 1, and the other thing's impossible. You can't have u minus v all squared is 2, so that's the only possibility. That then gives these triads, replacing v with u minus 1 and k is 2 in, gives you these three, and if you simplify these, you end up with this one, this and this. This is the hypotenuse, and it differs by 2 from the other side. It turns out that the other option doesn't work for you. If you've got k u squared plus v squared is equal to k u squared minus v squared minus 2, then you can show that leads to a contradiction. So that's question 24. And question 25 says, if a squared plus b squared is c squared, this is an old saw, this one, to prove that ABC has to be a multiple of 60. And it takes a little bit of doing to get there, so here's the word solution for this. So A or B, one of these two has to have this form, 2kuv. So if u or v is even, then 4 is a factor of one of them, and if not, then the other is ku squared minus v squared, and that is divisible by 2 if u or v are both odd. So that means 4 then has to be a factor of AB, the product ABC. So either you have 4 is a factor of this one, if not 2 is a factor of this one, and then 2 has to be a factor of this one. And in either case you get 4 divides A times B, and hence the product. Now if 3 doesn't divide A and 3 doesn't divide B, then modulo 3, we must have A squared plus B squared will have to be, each of these must be 1 mod 3, and some of their squares would be 2 mod 3, but 2 is not a square mod 3. So that's impossible, so that means 3 divides A or 3 divides B. So we've squeezed a 3 out of the product ABC. So at the moment that gives me 12, and finally to get the remaining 5, if 5 doesn't divide A and 5 doesn't divide B, then the only possibilities modulo 5 are 0, 2 or 3. Now 2 and 3 are not squares mod 5, and so the only possibility is that A squared plus B squared is 0 mod 5, and that means 5 then is a factor of C. So that means then out of that ABC we've got a factor of 4, we've got a factor of 3, we've got a factor of 5, and the product of those is 60, must be a factor of ABC. And that's the end of that little section.